Hey, welcome back. This is 6.4 now, working with some special forms. And first special form is, so we're doing the same stuff we've been doing before. It's just these kinds of things are, okay, so notice, what is x plus 8 times x minus 8? I'm just asking you to FOIL this thing. What the heck is it? So I would have x times x is x squared. That's the first. Then the outer, x times negative 8 is negative 8x. The inner, 8 times x is 8x. A little less, negative 8 times 8 is negative 64. Okay, combining like terms, negative 8x plus positive 8x, those are additive opposites. And you'll end up with just x squared minus 64, right? Because those two terms will cancel out. And so basically when you see two terms, you may have the possibility where you can do this type of factorization. So for example, if somebody gives you x squared minus 16, you can automatically say, well, it's going to be x and x, plus and minus, and then 4 and 4. And if you FOIL it back out, you'll see the two middle terms cancel. And so instead of dealing with a trinomial, you have a binomial that you're factoring, okay, into two binomials, I guess. But anyways, in general, you'll come across some object that will look like this: a squared minus b squared, and that will turn into a plus b times a minus b. Okay, so I mean the first big red flag is that now instead of like before we had something maybe like x squared minus I don't know, 2x plus 1. The big red flag here is that you just have two terms. Basically, you don't have that middle term, you just have the first and the last term. Okay? Sort of. It won't always be that easy, and this formula, you have to be careful. Because if that was a plus in between the a squared and b squared, it just wouldn't work. It would end up being prime, right? So just be careful. If you have a squared plus with a plus in the middle, that will be prime. Okay. But if you see this form, a squared minus b squared, it's usually pretty easy. One thing that we should have at our disposal here is maybe the list of perfect squares, because you're going to see numbers like 64, 16, 25. So when I first started, I would have like a little card, and I would have all these perfect squares on there. So for example, 4 is a perfect square because it's 2 times 2. And then 9 is a perfect square because it's 3 times 3, etc. So you should be kind of familiar with these numbers, hopefully, and that'll help you out a lot. Okay. So let's just give you the first like 13 of them. And hopefully you'll have these memorized by the time you're done with us. 8 squared is 64. You probably have most of these already kind of hopefully embedded in your brain somewhere. So I think the first 13 will be good enough. So, okay. Hopefully you have that sort of written down in your notes, and you can look back at that to help you as you go through the factorization. So anyways, just anything like x squared minus one of those guys, like x squared minus 121. You're setting up your parentheses. For this form, it's always plus minus, and it's x, okay? And then it's just figuring out, what times what is 121, and in this case, 11 times 11. And then if you FOIL it back out, clearly x squared, and then the outer minus 11x, the inner plus 11x, and then minus 121. Those cancel, and you get back to where you started. Okay, let's kind of make it a little bit more challenging by putting an extra term in there, extra constant in front of the x. So instead of x times x, we need two numbers, something times something, that give me 9x squared, right? So I'd say 3x and 3x. So it's plus minus, and then what times what is 25? 5 and 5. Okay. So both this thing in parentheses and this thing should be exactly the same, except they have opposite signs. Okay. When they have the same sign, that would be another form we look at here in a little bit. Okay. Let's get another one. So this one's kind of weird because we're used to seeing the variable in the first position, but they can put it in the second position. It doesn't matter. So let's go ahead and factor this. So it is it is this new form, the difference of squares. And what times what is 16? So that's 4 and 4, right? And then it goes plus minus, and what times what is x squared? Well, it's just x and x. And then you can FOIL it back out and see it works. This one always tricks people because they think, well, is 1 a perfect square? Yeah, it is. 1 times 1 is 1, right? And then you go plus, minus, 64. So you're kind of thinking, what is a square root, if you know what square roots are? The square root of 64 is just 8. So 8x times negative 8x will give me the negative 64x squared. Okay. And then we could even look at ones where we have higher exponents rather than just using x squared. You could literally have something like 49y to the 4th minus 25. So for the 49 part, 7 and 7, right? But for the y to the 4th, what times what will equal y to the 4th? Well, you can go y squared times y squared, right? So you have 7y squared times 7y squared will give you that 49y to the 4th. And then, of course, plus minus, and 5 times 5 is 25. Okay. Let's get another one. X to the 14th minus y to the 4th. Okay. So again, you're kind of trying to split this y to the 14th into two of the same thing multiplied by each other, right? And when you're thinking of multiplying variables that have the same base, what you're doing is adding the exponents. Okay, so x to the 7th times x to the 7th, what is that? That's the same thing as x to the 7th plus 7. And x7 plus 7 is 14, so that's one way to do. Okay, so you have x to the 7th times x to the 7th. And the same thing for y to the 4th. Y to the 4th, we already kind of did that one above in the previous example. That's just y squared times y squared. So you get plus y squared minus y squared. I think there's one on my math lab that's kind of a challenge problem. Oops, that's me uploading videos. That's me recording videos. And finally, the last one I check. Let's see where it is. I think it's number 36 or 37, maybe. No. That one's interesting, but this is the one that's kind of a really challenge problem. X to the 2n, and then minus 441y to the 2n. Okay, so what times what is x to the 2n? Well, you could rewrite x to the 2n using this idea of what plus what is 2n. N plus n is 2n, right? So you could rewrite this as x to the n plus n, and using the rules of exponents, that's the same as x to the n times x to the n. Okay? So hopefully you kind of remember, if you have a to the x times a to the y, that's the same as a to the x plus y. Okay? But you can go in the other direction too, right? So if you had 3 to the a plus b, you could rewrite that as 3 to the a times 3 to the b. Sorry about all the similar variables there. But anyways, this follows from the rules of exponents. So x to the 2n, you can think of that as x to the n times x to the n. Okay, so those are the first terms, plus minus. 441, what's the square root of 441? Or if you can kind of guess, right? So 13 ain't going to work. 14 probably not going to work. 15, 16, 17. I don't think anything's going to work. So 19 maybe, because 81 is kind of 19. 9 times 9. That's 361. That's still not good enough. 19, 20, 21 maybe. 4, yeah. Or you could just take 441 and do the square root on it and see if it works. It's 21. So we have 21y, and then that's kind of the same game, right? That would just be y to the n. This would be 21y to the n. Okay. There's another funny one in there. Let's look at that other funny guy. X plus 1 squared minus 100. How the heck am I going to do this, right? Well, what times what is x plus 1 squared? Well, let's think about that. X plus 1 squared is the same thing as x plus 1 times x plus 1, right? So I could put an x plus 1 in this position, and I could put an x plus 1 in this position. And then it's plus, minus, and then what times what is 100? That's one of our perfect squares in our list, right? It's just 10 squared. So 10 and 10. Okay. And then you could drop the parentheses on the x plus 1 if you want, and that would just be x plus 1 plus 10. And the other guy is x plus 1 minus 10. So that's going to be x plus 11 times x minus 9, if they want. X plus 11, x minus 9. Let's see if that works. X plus 11, x minus 9. Okay, so they really try to challenge you. Remember the golden rule for factoring. Always try to get the GCF first, okay? Look, basically you're always scanning to see if there is a GCF first. That'll make your life a lot easier. So let's take a look at some of those examples. 2x cubed minus 8x. You can factor out 2 from both terms. You can factor out an x. You'll be left with x squared minus 4. And then you could continue the factor. This part is just a difference of squares, right? So it'd be 2x times x and x. And then it's plus, always plus minus for differences of squares. And then what times what is 4? So just 2 and... Okay, so just a gentle reminder. Let's maybe look at maybe 1 or 2 more of those. Let's see. Example 32 minus 2y squared. So you can pull out a 2 from both. So you get 16 minus y squared. And then you can factor the 16 minus y squared. That's the difference of squares. Okay, so 4 times 4 is 16. That'll be plus and then minus. Or you can go minus plus. It won't make a difference. And then y and y. Another example, negative 4x squared plus 4. Well, you can factor out a negative 4 if you wish, and we'll end up with x squared minus 1. And then we can factor the x squared minus 1. So x plus, x minus, what times what is 1? And just 1, right? Okay, be careful again. Remember, there's this one little thing you gotta be careful of. If there's a plus in between the two squares, a squared and b squared, that thing's prime. And there's nothing you can do about it. Right? It is what it is. So, an example. kind of just thrown in the mix here if I can get my marker to change that to black. 4x squared plus 64. Sure, both of these guys, are perfect squares. 2x times 2x is 4x squared. 8 times 8 is 64. But there's that positive in between here. Okay, this here, and that's just going to mean it's prime. There's no way to kind of factor that, and you could even try. You could sit there for a while just by trial and error and go through every possibility, and you're going to be out of luck. It's just not going to work. Okay, so if you don't believe me, sit there and pause the video and maybe try to figure it out for a little bit. Okay. The next type is the what they call a perfect squares type, and that's what happens when you have a plus b times a plus b. So they basically have the same sign, or a minus b times a minus b. In these cases, when you FOIL, you're going to get 3 terms. So the big difference between this one and the previous examples, 3 terms here now. Okay, so we call these perfect square trinomials. And let's just notice kind of the FOIL direction going x plus 5 times x plus 5 and see what happens, right? So first we get x squared. The outer is 5x. The inner, we get the same thing again, 5x. And then the last, 25. Okay. So it's going to be x squared plus 2 of these 5x's. There's 2 5x's, right? Which is the same as 2 times 5x, 10x. Right? 5x plus 5x is 10x, same thing. And then plus 25. I wrote it like this because this indicates the general formula that we're going to be using. Okay, so in general, if you have something like a squared plus 2ab plus b squared, that's going to equal a plus b times a plus b. So in my example that I started with here above, the a is x and the b is 5. So you can see x squared is really a squared plus 2 times b is 5. So b, 2 times b, and then x is a, so 2ab or 2ba, those are the same things. And then plus your b squared. So it is this, it's basically this form. Of course, we have the other form as well, the a minus b times a minus b, which has the same form except the middle term is negative. Right? So you'll get negative ab minus ab, or in other words, 2 of them in the middle. In practice, I don't really memorize these forms. I just kind of given a trinomial, if I see the last term as a perfect square, for example, x squared minus 10x plus 25, if I see this as a perfect square, I kind of just guess my answer is going to be this form, right? And then I hope for the best. And 9 times out of 10, it turns out to work. Anyways, you of course want to FOIL it back out in your head and make sure it does work. So in this case, it has to be negative, negative because of the signs. The last times the last will be positive, and then when you add the inner and outer, you get a negative for the middle term. Anyways, okay, so yeah, let's FOIL it back out and make sure it works. So we have x squared, the first, and then the outer minus 5x, the inner minus 5x, and then the last plus 25. Yeah, that works. Okay. Let's try another one, x squared plus 24x plus 144. So 144 is one of our perfect squares, right? 144 is, whoops, I didn't include that one. Oh, I skipped 12. I'm so sorry, guys. I'm so sorry. I should have put 12 in there. I don't know how to count, apparently. 12 is 144, and then 13 is 169. Okay, so 12 squared, 144. So I'm just going to guess, it's going to be x plus 12, x plus 12. And if you add the inner and outer, 12 and 12 is 24. So I'm pretty sure that works. Okay. And the signs have to be plus plus because the last terms multiply to give you a positive, and then a positive plus a positive is positive. Okay. And sure, it works. X squared plus 12 to the outer plus the inner plus 1. Yeah, it worked. Let's try one with a where the leading coefficient is not 1. So 64y squared minus 16y plus 1. And again, I'm just going to presume it's kind of a perfect, it's one of these perfect square trinomials. Okay, so it's going to be minus minus for the signs. This has to be 1 and 1. 64 is 8 and 8, right? So 8y and 8y, and hope it works. 64y squared minus 8y plus 1, and it worked. Be careful. They're gonna start mixing in all kinds of problems together, and the next section will work on a general kind of strategy for factoring. But this guy, you may say to yourself, well, I think it has to be minus minus, and then 7 and 7, right? Let's factor it, FOIL it back out, x squared minus 7x. No, it's not going to work. Because it's going to be minus 7x plus minus 7x is minus 14x's, and we have minus 7x's. There's really no way to get that 7x in the middle. You could try 49 and 1, but you'd end up with like 50, minus 50 in the middle. So yeah, there's no way to do it. So this is kind of a trick question. It turns out to be prime. Okay? So you just write prime. Let's do one with multiple variables. X squared minus 18xy plus 81y squared. Okay. So let's say it's x and x. The signs have to be minus minus. 81 is 9 times 9. And then we need the y as well. So first, x squared, the outer, minus 9xy, the inner, minus 9xy, and then the last, plus 81y squared. And it works. Okay, again, what's the golden rule? GCFs. So remember to factor, I'm sorry about my handwriting isn't all that great. Factor out, hopefully you can read it, the GCF. If possible, right? So let's look at some of those. So here we have 2y squared minus 40y plus 200. And if you factor it out, you'll see it's a perfect square trinomial. Right? So let's get that 2 out of there. We have a y squared minus 20y plus 100. And then 100 is just 10 squared. So I think it's a perfect square, and I'll try that. So we have y minus, and it's 10 and 10. So let's make sure it works. Y squared minus 10y minus 10, yeah, it works. Okay, so that would be our answer in the box there. This next one's a video quiz. So this is the video quiz question du jour. So this will be the last problem in the video quiz, homework number 1. You should have 6.1, 6.2, 6.3, 6.4 video quiz questions on one page. And then you're going to take a picture of it, upload it to the computer, turn it into a PDF document, and then send it to my email. Okay. So anyways, the video quiz question, negative 45y cubed minus 30y squared minus 5y. Okay, so I have a leading negative. I don't like those negatives, so I'm going to factor that out with the GCF. So I have a negative, and it looks like I could factor out a 5 from each term and also a y. Okay, so I'll end up with 9y squared plus, because I have to change the sign, I factor out a negative, so plus 6y, and then plus just 1. Okay, it looks like the first and the last term of that trinomial are perfect squares, so I'll try to turn it into a perfect square trinomial, try to factor it into this form. It'll have to be plus plus, 1 times 1, and we're hoping 3y times 3y will do the job. Okay, does that work? So 9y squared plus 3y, yeah, plus 3y. Okay. And then that would be your final answer. Don't forget that negative 5y that's sitting in front. You can take some of the pressure off of your answer if you wish. You can always write negative 5y times 3y plus 1 squared. If you want to do that, that's fine. I'm pretty sure that will work in your homework as well. Let's just make sure, right? Let's get one of our perfect square problems. Okay, so this one is weird exponent. So it's going to be x to the 6 minus, oh, this is a difference of squares. I need a perfect square trinomial. Sorry. 15, nope. Skip the 20, yes, okay. So this is going to be 7x minus 1 squared. Let's see if they let us write it like that. Yeah, okay, so you can write it like that, or if you want to, you can just brute force write it out. I think this one's prime. That's a rare oddity. You can write it like that, or you can just multiply, x plus 5y times x plus 5y. Let's see, instead of x plus 5y squared, right? Yep, either way is good. Okay. The next form are cubic types. Okay, so let's take a look at these things. And these are usually hard to remember, but there's kind of like ways to remember it. This is the sum slash difference of two cubes instead of like a difference of two squares. Difference, that should be an R, of two cubes. Okay, so the forms are a cubed minus b cubed, and this is why it's hard to remember. So it's minus b and then a squared plus ab plus b squared. Okay, and then the other form, a cubed plus b cubed, is going to be a plus b. It's all the same variables, but the signs are a little bit different. Minus ab plus b squared. Okay, so to remember how the signs work, we have the SOAP, use SOAP. So same sign, opposite sign, always positive. Okay, so when I say same sign, I mean it's the same as the beginning, as the sign and the given expression. Okay, so that's minus because it's the same as this. And then you use the opposite sign, the opposite of what's given. And then the third term is just always positive, no matter what, right? So if you use SOAP on the second one, you see same sign is positive, and then the opposite sign is negative, and then finally always positive. Okay? You do have to have these memorized for the test. Okay? All right. One way to memorize it is just, brute force. Write it out over and over and over until you got it memorized. That's just one of the weird peculiarities of math. You got to figure out ways to memorize these kind of weird things, So, okay, so let's try some of these. And being familiar with perfect cubes now becomes really advantageous. So before I gave you a list of perfect squares, now it's probably a good idea to kind of have a list of perfect cubes. So you can generate your list, just take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is usually enough, and then cube them and see what numbers you get. So 8 is a perfect cube. 3 times 3 is 9, 3 is 27, this is 64, 125, and then I'm out of running room. I think it's 216, but I don't remember. So let's come to the calculator. 6 cubed is 216. 7 cubed. 343. And I wouldn't expect you to know anything beyond 5 cubed off the top of your head. Some people who work in certain areas of computer programming, they'll know it just because it's part of their job. Like if you work at McDonald's, you know how to fry up the quarter pounder on that press thing, right? Yes, I have worked at McDonald's. 512.9 cubed. 729. And then 10 cubed, I presume, is 1,000. Just has 3 zeros on it, right? 10 to the 4th will have 4 zeros. So 3 zeros to the 4th. Oops. 10 to the 4th. There's 4 zeros. So 10 to the 5th will have 5 zeros. Yeah. Pattern there. Okay, so hopefully somewhere you have these kind of for reference if you need them in the beginning, and then hopefully you kind of become familiar with the numbers. Let's take a look at doing these. Right? Okay, so the example, x cubed minus 64. Okay. The way I do these is usually identify what is A and what is B. I don't really do that in the other problems, but for this I think it helps. So basically you're doing what's called a cube root. So what times what is equal to x cubed? Well, x, right? And then what times what is equal to 64? If you look back at your table, 4. And then you just are plugging and chugging into the formula. So it's going to be, let's get the signs together. So same, opposite, always positive. And then it's going to be x minus 4, and then a squared is x squared, and then a times b is 4x, and then b squared is 16, and that's it. Usually you can't factor the second trinomial, okay? 99% of the time, so I usually don't even bother. Let's see. I would have to prove that, It's like I was saying in the other video, if I drove 100 miles to work every day and got away with it, that doesn't mean it's always going to work, right? So anyways, what's A in this case? So what cubed is 125? That's 5. And then x, right? So x times x times x is x cubed. And then what cubed is 8? And that's just 2. Okay. So let's set up our parentheses, put the signs in. So it's same, opposite, always positive. Okay. So 5x and 2. And this, people always screw up. They want to put 5x squared in this first position, but it's really 5x squared like that. So you're going to be putting in 25x squared. And then the middle one, 5x times 2 is 10x. And then the last is 4. Okay. So ultimately you're going to have 5x plus 2 times, not 5x squared, 25x squared. Freshman mistake. Let's get a couple more, and then we'll go to my math lab. Maybe just one more. Again, the cardinal rule. factor out any GCFs. Okay. So in this example, we have 64y minus y to the fourth. Okay. So it doesn't look like one of these differences of cubes, right? And in this case, it kind of almost looks like a difference of squares, but it's not. And you can see that when you factor out a y. So pull out a y and you get 64 minus y cubed. If you want to, you pull out a negative y and make it look prettier. So you'd have negative y times y cubed minus 64. But this will work in the same way. In this version, so there's sometimes more than one way to factor it. And you just have to read the directions in the problem if they want you to factor out the negative or not. But anyways, the a in this version is 4. And then the b value is going to be y. Okay. So that y times something times something. So same, opposite, always positive. And then it will be 4 minus y. And then a squared is 16. A times b is 4y. And finally, b squared is y squared. Okay. Okay, so that's pretty much the deal. The big and the small of it. Let me go into MyMathLab and see if there's anything crazy that we need to deal with. Right? Okay. So, Rich, let me do my setup a little bit differently so I can see what I am working with. Okay. So, let's see if there's the hard ones. I think we already kind of looked at the last kind of. All right, so this is one just like what we did. 343y to the fourth plus 216y. I could factor out, I don't think I could factor anything out of the numbers, but I could factor a y out. And then if you look at your list of perfect cubes, those seem like perfect cubes to me. 343 is 7, 216 is the 6 cubed. Okay. So in this case, A will be, what did I say? 7 is 343, so 7y. 7y times 7y times 7y is 343 cubed. The 343y cubed. And then the B will just be 6. Okay. So this will be y times well, get the signs first. So same, opposite, always positive. And you have 7y, and then 6. And then again, it's not 7y squared. It's 49y squared. And then 42y. That's 7y times 6 is 42y. And then plus 36. Let's see if we got it. Plus 6 times 49y squared minus, oops, the exponent, minus 42y plus 36. Okay. Okay, so they got a multivariable one. I don't think we looked at one of these. So 64x cubed plus 125y cubed. So the A value here is 4x, and then the B value here is 5y. So we're going to get same, opposite, always positive. So 4x plus 5y. 4x squared is 16x squared. And then 4x times 5y is 20xy. And then finally, b squared would be 25y squared. Let's pop that in there so it works. Is 16 13 x squared minus 20xy plus 25y squared exponent. Oh, some of these fraction ones. Okay, I didn't do any of those, sorry. I was so excited about it. There's not much going on in my life, apparently, to get excited about this, but here we go. Okay, so this is difference of squares. I don't see any common factors, so I'm just going to go plus minus, and hope it's a difference of squares, right? So what times what is 4x squared is 2x times 2x. And then you could see in the numerator, the 169 is basically just 13 squared. So you can put 13 and 13 here. And then 225, what the heck is that? That's, I think it's 25 squared. Or 15 squared. Let me see. Yeah, so 15 times 15. So just put that in the denominator, and then that should take care of it. X plus 13 for fractions, they're underneath the question mark. You just hit the slash, and then that will give you a fraction. So minus 13 slash 15 out of there. Check answer. And this character, so this one has a GCF, x to the 5th minus x squared over 64. I can pull out x squared, so I end up with x cubed minus 1 over 64. And then that's a difference of cubes. So the a value is x, and the b value, if you look at the denominator, that's just 4 cubed. Okay, so b is going to be 1 all over 4. 1 over 4 times 1 over 4 is 1 over 16. Times 1 over 4 again will give you 1 over 64. Okay. So this is going to end up being x squared times, same, opposite, always positive. So we have x minus 1/4. And then we have x squared plus 1/4 x, or if you'd rather x over 4, doesn't matter. And then 1/16, 1/4 squared. Don't forget the x squared in front. So minus 1 slash 4, parentheses, parentheses, x squared plus x slash 4 plus 1 slash 116. Ooh, a decimal. So you could take x out of this example first off. So 0.25 x minus x cubed. You can factor out an x. And then it looks like it's just a difference of squares. So you have to kind of be careful. What's the square root of 0.25? Right? Is it 0.5 or is it 0.05? At least it's 0.5. But anyways, you could always go 0.25 and then just take the square root and do 0.5. So this will be x times, it's a difference of squares, so it's going to be 0.5 plus, and then 0.5 minus, and the other one is x and x. Use integers, okay. So x times 0.5 plus x times 0.5 minus x. Anything else weird? I did that one. I did that one. Let me do a random one. Okay, so this is a difference of squares. This will be the last one, and I'll let you go. 25 y to the 4th minus 4. Okay. There's no common factor, so looks like we have what times what is 25y to the 4th? Well, 5 times 5 for the 25 part, and then y to the 4th is the same as y to the 2 plus 2 and that's the same as y squared times y squared. So 5y squared, and then plus minus, that would have to be 2 and 2. So again, the difference of squares, you can really tell because there's only 2 terms there. So, and if there was a plus in between them, you'd kind of be stuck. 5y squared plus 2, 5y squared minus, whoops, minus 2, and answer. Okay, so we'll let you go and get all the homework done. A lot of homework, but it's good practice for you, and we'll see you in the next video.